Hi, my name is Jason Stein, and this is a problem on circular motion. A bucket of water is whirled in a vertical circle of 75 centimeters. What is the minimum speed that will keep the water from falling out of the bucket? So here I have a little diagram. You can see the bucket, and the radius is 75 centimeters. We have two forces acting right here. We have the force of gravity, which will be your mass times the gravity, and that'll be acting on the bucket. We will also have the normal force acting on the water inside the bucket. So let's go down and look at this. Our net force is going to be equal to the mass times the acceleration vector, which you can see here. And the net force is going to be in the radial direction, so that's going to be equal to the mass times the radial acceleration, as you can see here. So our radial acceleration is going to be equal to our velocity squared divided by the radius. So here we take our our forces, which will be our normal force plus the gravitational force, which we defined as mass times the gravity, is equal to the mass times the velocity squared divided by r, which we defined as that was the radial acceleration. And the velocity squared is what we are looking for. So we would like to separate the v and get it by itself. So, we move a few things around, divide by the m, and it'll cancel our masses out on over here, and then we will times it by the radius. Once we take the square root, we'll get v is equal to radius times the normal force divided by mass plus the radius times the gravity. So as you can see, we are looking for the minimum speed, and at that minimum speed our force normal is going to 0. So we put Vmin is equal to the square root of our radius times 0, because our force normal is going to 0, divided by the mass plus radius times gravity. So our first variable, it gets canceled out, and all we're left with is a square root of radius times gravity. So all we have to do now is plug in our data, and as you can see, we get Vmin is equal to the square root of 0.75 meters times 9.81 meters per second squared. Then all you do is solve for that, and we get the minimum speed, the minimum velocity in which the bucket must be going so the water will not fall out is 2.7 meters per second. Thank you.